first system of steam power plant is coal handling plant. The coal is transported to the steam power station by road or rail and is stored in the coal storage plant. Storage of coal is primarily a matter of protection against coal strikes, failure of the transportation system, and general coal shortage. From the coal storage plant, coal is delivered to the coal handling plant, where it is pulverized, for example, crushed into small pieces, in order to increase its surface exposure, thus promoting rapid combustion without using large quantity of excess air. The pulverized coal is fed to the boiler by belt conveyors. The coal is burned in the boiler and the ash produced after the complete combustion of coal is removed to the ash handling plant and then delivered to the ash storage plant for disposal. The removal of the ash from the boiler furnace is necessary for proper burning of coal. Equipment that used in a coal handling plant is pull cord switch. A series of such switches are arranged in series at 1 meter distance on the side of conveyor belt. The power supply to rotor of the conveyor belt is established only if all switches in series are connected. Next, vibrating feeder. The coal stored in a huge hub is collected on the belt through vibrations created by the vibrating feeder. Then, flap gates. These are used to channelize the route of coal through another belt in case the former is broken or unhealthy. The flap gates open let the coal pass, and if closed, stop its movement. Magnetic separator. These are used to separate the ferrous impurities from the coal. Metal detector. The transmitter consists of a high-frequency oscillator, which produces oscillations of 1500 Hz at 15 volts. The receiver receives this frequency signal if there is any presence of metal in the coal. Then this frequency is disturbed and a tripping signal is sent to relay to stop the conveyor belt. Belt weigher. It is used to keep an account of the tension on the belt carrying coal and is moved accordingly to release tension on the belt. Reclaim hopper. Reclamation is a process of taking coal from the dead storage for preparation of further feeding to reclaim hoppers. This is accomplished by belt conveyors.
Steam generating plant. The steam generating plant consists of a boiler for the production of steam and other auxiliary equipment for the utilization of flue gas. First, boiler. The heat of combustion of coal in the boiler is utilized to convert water into steam at high temperature and pressure. The flue gas from the boiler make their journey through superheater, economizer, preheater, and finally exhauster to atmosphere through the chimney. Second, superheater. The steam product produced in the boiler is heated and is passed through at superheater where it is dry and superheated. The steam temperature increase above that of the boiling point of water by the flue by the flue gas on their way to the chimney. Superheater provides two principal benefits. Firstly, the overall efficiency is increased. Secondly, too much condensation in the last stage of the turbine, which will cause blend corrosion is about. The superheater steam from the superheater is fed to the steam turbine through the main valve. Third, economizer. An economizer is essentially a feed water heater and derives heat from the flue gas for this purpose. The feed water is fed to the economizer before supplying to the boiler. The economizer extracts a part of the heat of flue gas to increase the feed water temperature. A preheater An air preheater increases the temperature of the air supply for cool burning by deriving heat from flue gas. Air is drawn from the atmosphere by a forced draw fan and heat passed through a preheater before supplying to the boiler furnace. The preheater extracts heat from the flue and increases the temperature of air using for the cool combustion. The principal benefit of preheating the the condenser which condenses the escape stream by means of the cool water crystallization.
Next, cooling arrangement. In order to improve the efficiency of the steam power plant, the steam exhausted from the turbine is condensed by means of a condenser. Water is drawn from a natural source of supply such as a river, canal or lake, and it circulates through the condenser. The circulating water takes up the heat of the exhausted steam and itself becomes hot. This hot water coming out from the condenser is discharged at a suitable location down the river in case the availability of water from the source of supply is not assured throughout the year. Cooling towers are used during the scarcity of water in the river. Hot water from the condenser is passed on to the cooling tower where it is cooled. The cold water from the cooling tower is reused in the condenser.
The steam turbine is composed to an alternator. The alternator converts mechanical energy of the turbine into the electrical energy. The electrical output from the alternator is delivered to the bus bar through transformers, current breaker, and isolator. The generator alternator is the heat of the generator. The alternator also refers to the gen heat is the part of the produced electrical energy from the mechanical energy supplied to it by the engine. An alternator comprises a stator, a stationary component, and a rotor, a moving component. When both the components work together, a relative movement between the magnetic and electric fields is generated, which is then produce electricity. The generator alternator works on the principles of the electromagnetic inductions. According to the principles, when the presence of the magnetic fields and electrical conductor, such as a wire containing electrical charge is moved, is a result in a voltage difference between the two ends of the electrical conductor, which causes the movement of electric charge through the wire, thereby generating electricity. The rotor, also known as the armature, is movable part of the alternator that produce the rotation magnetic fields in a three different ways. First, in the inductions, you have this mechanism in large generator. You also know them by the names brushless generator, permanent magnets. Small gensets have permanent magnets that provide that stationary magnet fields. The rotor converts this stationary magnet.
My name is Nurul Ain Ashira binti Hazhar. My registration number is 01 DKM 19F1186. We go to the next system is water feeding arrangement. What is feed water system? It is prepares the water for reintroduction into the boiler. This preparation includes aeration, collecting in a feed water tank, and pumping the water to the boiler. There are two types of feed water tank. First is atmospheric tank, and second, fully pressurized feed water generators. Okay, what is a feed water treatment? Feed water treatment is a pre-water treatment process to control deposition, eradicate impurities, and prevent corrosion within a boiler system. In a boiler system, water is transformed into steam and expanded by as much as 1,000 times as it passes through steam pipes at rates of 100 km per hour. The feed water pump takes a suction from the feed water tank and provides hot feed water directly to the boiler. When the boiler's level control system sends a low operating water level. Feed water systems can maximize the life and efficiency of a wide variety of boilers. The feed water lines run from the feed water regulating valve station in the turbine building to the reactor building and hence to each steam generator. The condensate from the condenser is used as feed water to the boiler. Some water may be lost in the cycle, which is suitably made up from external source. The feed water on its way to the boiler is heated by water heaters and economizer. This helps in raising the overall efficiency of the plant. Okay, this system have advantage. I want to talk some of the advantages. Okay, first is reduce risk. Second, reduce external treatment cost. Third, remove or reduce hazardous acid and caustic chemicals. And fourth, improve operation and steam purity. Okay, water treatment technologies for thermal power plants have been examined and improved as a countermeasure against equipment damage due to factors such as corrosion and scale deposition. Water treatment for thermal power plant is conducted to prevent problems such as carryover to the turbine components, as well as corrosion and scale formation or deposition in the boiler and turbine system. Since 1959, water treatment methods have been improved to deal with equipment non-conformities.
A steam turbine is a machine that extracts thermal energy from pressurized steam and uses it to do mechanical work on a rotating output shaft. Its modern manifestation was invented by Charles Person in 1884. Fabrication of a modern steam turbine involves advanced metalwork to form high-grade steel alloy into precision parts using technologies that first became available in the 20th century. Continued advances in durability and efficiency of steam turbines remain central to the energy economy of the 21st century. The steam turbine is a form of heat engine that derives much of its improvement in thermodynamic efficiency from the use of multiple stages in the expansion of the steam, which result in a closer approach to the ideal reversible expansion process. Because the turbine generates rotary motion, it is particularly suited to be used to drive an electrical generator. A steam turbine connected to an electric generator is called a turbo generator. Turbine types include condensing, non-condensing, reheat, extraction, and induction. First, condensing turbines are most commonly found in electrical power plants. These turbines receive steam from a boiler and exhaust it to a condenser. Second, non-condensing or back pressure turbines are most widely used for process steam application, in which the steam will be used for additional purpose after being exhausted from the turbine. The exhaust pressure is controlled by a regulating valve to suit the needs of the process steam pressure. Third, reheat turbines are also used almost exclusively in electrical power plants. In a reheat turbine, steam flow exists from a high-pressure section of the turbine and is returned to the boiler where additional superheat is added. The steam then goes back into intermediate pressure section of the turbine and continues its expansion. Extracting types turbines are common in all applications. In an extracting types turbine, steam is released from various stages of the turbine and used for industrial process need or sent to boiler feed water heaters to improve overall cycle efficiency. Induction turbines introduce low-pressure steam at an immediate stage to produce additional power.
Back to me again. I am Aina Ashira. Okay, I want to present the last system. It is ash handling arrangement. What is ash handling? Ash handling refers to the method of collection, conveying, interim storage, and load out of various types of ash residue left over from solid fuel combustion process. About 80% of the ash that is generated in a thermal power plant is fly ash, with the remaining 20% being bottom ash. In the last 15 to 20 years, it is a trend worldwide to use dense space pneumatic conveying for fly ash collection and handling within a power plant for different environmental, economic, and product benefits. Okay, they have three main kinds of ash handling system. First is hydraulic system, second is pneumatic system, and third is mechanical system. Okay, we go to the hydraulic system. In this system, ash from the furnace grate falls into a system of water traveling at a high pressure and is carried to the sump. For pneumatic system, in this system, ash from the boiler, ash outlet falls into a blow tank provided below the ash hopper. And then lastly, mechanical system, cooled ash falls on the batch conveyor and is carried out continuously to the bunker. Ash handling system may employ different forms of pneumatic ash conveying or mechanical ash conveyors. A typical ash handling system may employ vacuum pneumatic ash collection with ash conveying from several ash pickup stations and resulting in delivery to an ash storage silo for interim holding prior to load out for disposal or reuse. Pressurized pneumatic ash conveying may also be employed. Why ash handling is needed in thermal power plant? In thermal power plants, an ash handling system is used to collect and dispose of discharged ash. Once it has been cooled down to a manageable temperature, which is then used in various industries like construction, cement plants, and other allied industries. Coarse ash materials such as bottom ash is most often crushed in clickers grinders, prior to being transported in the ash conveyor system. Very finely sized fly ash often accounts for the major portion of the material conveyed in an ash handling system. It is collected from baghouse type dust collectors, electrostatic precipitators, and other apparatus in the flue gas processing stream.